In the night sky, just 20 light-years away, a planet could potentially harbor liquid water, one of the fundamental ingredients for life as we know it. That's exactly what has scientists buzzing with excitement about HD 2779 Ford, a super-Earth that has just been confirmed orbiting a sun-like star within its habitable zone. In this video, we're breaking down everything you need to know about this thrilling discovery, exploring how it was confirmed, what we know about the planet itself, and what it means for future space discovery and confirmation process exploration. The story of HD 20794D began in 2022 when Dr. Michael Creanier from the University of Oxford detected an unusual signal while analyzing archived data from the HARPS, High-Accuracy Radial Velocity Planet Searcher, spectrograph located at La Silla Observatory in Chile. This signal hinted at the possibility of a nearby exoplanet, but the evidence was weak. The signal strength was close to the detection limit of the spectrograph, making it difficult to determine whether it was caused by an orbiting planet, activity from the star itself, or even an instrumental error. Rather than dismissing the signal, an international team of researchers took on the challenge of confirming its existence. The team analyzed over 2 decades of precise measurements from HARPS and Espresso, another powerful spectrograph located in Chile. These instruments are specifically designed to detect tiny variations in light spectra, helping scientists measure how a star's light shifts due to the gravitational pull of orbiting planets. The process of confirming this planet wasn't easy. Scientists had to filter out noise, remove potential distortions from the instruments, and ensure the signal wasn't a false positive. After years of advanced data analysis, they finally confirmed the planet's existence. Now that we know HD 20794D exists, what makes it so interesting? The first major point is its location. It orbits a G-type star similar to our Sun in the constellation Eridanus, just 20 light-years from Earth. That's relatively close in astronomical terms, meaning future space telescopes will have a much better chance of studying it in detail. One of the key reasons why scientists are excited is because this planet lies in the habitable zone, the region around a star where temperatures might allow for liquid water to exist. But here's where things get tricky. This planet doesn't have a stable circular orbit like Earth. Instead, it follows an elliptical path, meaning that during some parts of its orbit, it moves closer to its star, and at other times, it drifts farther away. This variation could lead to dramatic climate changes, affecting its potential to sustain life. When it's closer to the star, it might experience extreme heat, potentially causing water to evaporate. When it moves farther away, it could become too cold, freezing any existing water. If the planet has a thick atmosphere, it might help regulate these temperature swings, but until we can directly observe its atmosphere, its true habitability remains a mystery. In terms of size and composition, HD 20794D is classified as a super-Earth. It has 6 times Earth's mass, but astronomers aren't sure whether it has a solid rocky surface or if it's a mini Neptune with a thick gaseous atmosphere. If it's rocky with a stable atmosphere, it could have conditions similar to Earth. However, if it has high levels of hydrogen and helium, it might resemble Neptune more than our home planet, making it far less hospitable to life. Advanced telescopes will analyze the planet's atmosphere to look for biosignatures, chemical signs of life such as oxygen, methane, or carbon dioxide. If such signatures are detected, it could be one of the most groundbreaking discoveries in human history. The discovery of HD 20794D introduces another promising candidate in the search for habitable exoplanets. However, its elliptical orbit poses a challenge. Fluctuating distances from its star could lead to extreme temperature variations, impacting the planet's ability to sustain stable conditions for life. If it possesses a dense atmosphere or strong greenhouse effect, it may regulate its climate and maintain liquid water, a crucial ingredient for life. Without these factors, the rapid shifts between heating and freezing could make habitability unlikely. Geological activity is another key consideration. On Earth, volcanic activity and a dynamic interior help regulate the climate and sustain life. If this planet is geologically active, it could replenish its atmosphere and support a stable environment. Conversely, If it lacks a protective magnetic field, its atmosphere may erode over time due to stellar winds, diminishing its habitability. Beyond it, other exoplanets have sparked interest due to their potential habitability. Proxima Centauri b, just 4.2 light-years away, is the closest known exoplanet in a habitable zone. However, it orbits a red dwarf star, which emits intense radiation, possibly stripping away its atmosphere. The TRAPPIST-1 system, about 40 light-years away, features 7 Earth-sized planets, 3 of which, TRAPPIST-1e, F, and G, reside in the habitable zone. These worlds, though promising, are tidally locked, meaning one side is in perpetual daylight while the other remains in darkness. A balanced atmosphere could mitigate this and allow for stable climates. Another strong candidate is Kepler 442b, located 1,200 light-years away, which is considered one of the most Earth-like exoplanets. It receives about 70% of Earth's sunlight, suggesting mild temperatures that could support liquid water. Similarly, TOI 700d, a rocky exoplanet 100 light-years away, orbits within the habitable zone of its M-dwarf star, with fewer solar flares than most red dwarfs, increasing its likelihood of retaining an atmosphere. While these exoplanets are promising, the next step is determining whether they actually harbor life. Upcoming telescopes like NASA's Habitable Worlds Observatory, the Extremely Large Telescope, YELT, and the LIFE mission will analyze distant planets' atmospheres, searching for biosignatures such as oxygen, methane, carbon dioxide, and water vapor. Detecting these gases in the right balance could be a strong indicator of biological activity. Interstellar probes could also revolutionize exoplanet research. Projects like Breakthrough Starshot propose sending light-powered spacecraft to explore exoplanets like Proxima Centauri b. If successful, similar missions could target HD 20794d, allowing us to study these distant worlds up close. Ultimately, the discovery of HD 20794d contributes to a bigger question. Are we alone in the universe? With billions of stars and planets, it seems increasingly likely that habitable worlds are common. The challenge lies in detecting them and proving that life exists elsewhere. Thank you for watching. Stay curious and keep looking up. If you enjoyed this video, don't forget to like, share, and subscribe for more exciting content about space, science, and the mysteries of the universe. Hit the notification bell so you never miss an update on the latest discoveries. Let us know in the comments. Which exoplanet do you think has the best chance of hosting life? We'd love to hear your thoughts.